My voice is kind of going away. I'm getting kind of sick, so you'll have to not talk when I'm teaching for sure. Okay, so this one's pretty easy. I feel like you could even just verbally state it probably, this one. Before we get started on today's lesson, I'm just seeing if you can still think a little bit critically. This one's not even that bad, right? Triple the amplitude, decrease the midline by 4 units. What's the new equation? Okay, you said, one more time. So you said 9 sine of, so that didn't change, the pi halves? Okay. Now, how'd you know the minus 4 was out here, not in here? Yeah, good. It's down 4, it's just up and down on the outside of our parentheses, right? What if they would have given you a period change? Like, what if they would have said, and twice the period? Now, you got to be careful, because a lot of people just times that by 2. That wouldn't be true, right? If you have twice the period, what would that become? Would it be pi fourths? Let's do some math and find out. So what would the original period be, everybody? 2 pi divided by pi halves, true? Which is 4, yeah? Now, twice the period. This is the original period. What would twice the period be? 8. So now we would set up 8 is equal to 2 pi over b, and then solve for b. So you were right when you guys said we times up by b, divide by 8. So b is equal to pi fourths. Way to think. Way to think. You guys see how we're getting pi fourths? Okay, just curious. I might throw one like that on the next test just to keep you thinking about that stuff. All right, let's go on to the last lesson of the unit. We'll get back from spring break, review, and then test. All right, we're just learning some last identities. These are the final identities that are on your sheet. These ones are the double angle formulas, which, look, makes sense. Look at sine of 2u. Do you see how it's twice the angle? Cosine of twice the angle, tangent of twice an angle. So these are called double angle formulas. What the heck? Not product to sum formulas. We're not learning that. I've never noticed that. My instructions say that ever. All right, so double angle formulas, you guys, are a way to take something and instead of having a 2 inside our parentheses, to write it with just a u instead of 2u. That will be useful in a lot of cases. Now with solving, this isn't a problem, right? The 2u is not a problem when solving. Remember, we just find our solutions like normal, correct? Times them by a half. But there are times when this is going to be a pain in our butt. So everybody look here. You're not going to have to memorize these ones. These are the ones to make yourself know. I don't have these ones memorized, so I'm not going to make you memorize them. So you might want to make yourself know. These are the ones I'll have written on the board. Other ones I won't. I'll tell you which ones I will. There'll be a couple. So these 3 I definitely will. So notice sine of 2u can be written as 2 sine u cosine u, which is helpful in times when we have to just have u instead of a 2u to calculate something or simplify something. So cosine of 2u can be switched to 3 different things. They're all equal mathematically. So we could, if we chose, change cosine of 2u to cosine squared minus sine squared u, that would be fine. We could also, if we so chose, to switch it to 2 cosine squared u minus 1. And if we also wanted, we could switch it to 1 minus 2 sine squared u. Now we could, you guys are seeing where we're getting that, right? Because we know that sine squared is 1 minus cosine squared and vice versa. So it's just we can switch it to any 3 and mathematically it will simplify to be the same thing. There are times when it just might be quicker if you choose the correct one. But if you choose, there's not a wrong one. It's just if you choose one, it might not simplify as quickly as another one. And then tangent, really guys, is just sine over cosine. So a lot of teachers, once again, they don't teach tangent because you can just do sine of 2u over cosine of 2u. But I do like to have it as well because sometimes it's more straightforward just to type it into the formula. Sometimes I just do sine over cosine. All right, double angle formulas. You've got them down. Also, please have a unit circle in front of you. I don't have a unit circle on my picture for today's lesson, so I'm just going to have you guys look at your own unit circles, please. Okay, now all we have to do is start practicing some of these. So notice in this problem, we are given the problem, solve 2 cosine of x plus sine of 2x equals 0. Now, if this would have just been 2 cosine of x plus sine of x, I would have subtracted sine of x over, and then I would have squared both sides, because we would need to switch it all to sines or cosines. Does everyone see? But the problem is we have a 2 in front of our x. We can't solve this one. Now, if it was just 2 sine of x equals 0, it'd be okay. We could solve like normal. But because it's just cosine of x and then sine of 2x, we can't solve. So we need everything to have just x's. So what we would do is we would take our identity and we would rewrite this as something equivalent. So this is 2 cosine of x And then plus, instead of sine of 2x, let's write it with just x's. Wouldn't that be this? So that'd be 2 sine of, I already wrote cosine, but that's fine, doesn't matter. Cosine x sine x. I just reordered it, but times can be reordered. You guys see what I did? Now, that's going to be easy to solve because how do we solve? Either we isolate the trig function or we factor it. Won't this one be a factoring problem? When factoring, we get it set equal to 0, factor out greatest common factor, so let's pull out 2 cosine of x. So then divide by 2 cosine of x, divide by 2 cosine of x. So then left in our parentheses is 1 plus sine of x. And now that we have it factored, and notice in our equations there's only x's, we can just set each of them equal to 0 and solve. So 2 cosine of x equals 0, 1 plus sine of x equals 0, and then solving for x. So we divide both sides by 2. We're looking for when does cosine of x equal 0. Alright, now it's infinite solutions, so let's go ahead and write out our solution set. Cosine equals 0 at the first place around the unit circle is pi halves, isn't it? Because cosine's x, so pi halves, and then the next place is 3 pi halves. Now, wouldn't it be more appropriate to just list out pi halves and then plus or minus pi n, because that would be the least amount of solutions possible to list if possible. That would take care of our 3 pi halves. Okay, good. Now let's solve this one. We would have when does sine of x equal negative 1? Now once again, if you look at your unit circle, doesn't that happen at 3 pi halves? Now look, do I need to list that or is it double dipping? It's double dipping, isn't this also the solutions of, guys, if we start at, look, right here's pi halves and here's 3 pi halves. If we were listed out the solution as pi halves and then added pi, we already took care of 3 pi halves. So once again, we would just cross that solution out because it's not necessary to list it again. So that's our answer. Pi halves plus or minus pi n. So I have had people ask me, which was a valid question, what if I listed out pi halves plus or minus 2 pi n and 3 pi halves plus or minus 2 pi n? Your answer's not wrong. I couldn't mark you completely down. I wouldn't. Your answer just has too much information listed. Not necessary. So I would dock off some, but it wouldn't be wrong. Does that make sense? So just pay attention to those little things because obviously the little things add up, as we know. All right, that will take you from your A to your B. All right, this one, everyone write down. This one often gets to people. So there are going to be times, guys, when you actually have to manipulate something and rewrite it with a trig identity that is a little bit trickier to see right off. So it kind of, the instructions give us a hint of what we maybe should do. So it says y is equal to 4 cosine squared of x minus 2. Basically, it's asking us to graph in a way because it says what's the amplitude period, what's the max and min values, and what's the x-intercepts. Now, if you notice, we've only learned in this class how to graph sine x, cosine x, tangent x. We didn't graph any squareds, you know what I mean? We didn't graph them times to each other. We'd rather just have it degree 1 versus degree 2. If it was just cosine of x, no problem. So let's see if there's a way we can rewrite something. Now, just a reminder, to simplify something, oftentimes if there's 2 terms and there's something in common, like a greatest common factor, try factoring it out to see if it will help you. It might not help you, but it might. So in each term, isn't there something in common? So let's pull out a 2, so then divide by 2, divide by 2, so then left would be this. 2 cosine squared of x minus 1. Now you'd have to be watching with an eagle eye to catch what you could rewrite this as. Yeah. Now, once again, this could be written, we can go back and forth. Do you guys see how this and this are the same thing? So can't I rewrite it as this, cosine of just 2u, or cosine of 2x? And that would be better because then it's linear, and we know how to graph that. So we have y is equal to 2, and instead of that, we're going to write it as cosine of 2x. And now it looks like something we've graphed in the past. So now easily we can say our amplitude is 2. Our period is 2 pi divided by b, so that's 2 pi divided by 2, which is pi. Our max and min and x-intercepts I would find by making my quick xy chart. I would just do it for cosine of x and then shift it. So 0 pi halves pi, 3 pi halves 2 pi, and then cosine is max 0, min 0 max, isn't it? So I would quickly just perform the transformation and then state my max, mins, and x-intercepts. Aren't we going to times our y values by 2 for our amplitude? And our period needs to end at pi. It's ending at 2 pi. Don't we times by 1/2, the reciprocal of b. So we'll write down our official new xy points, and then we'll have our answers. A half times 0 is 0. Pi halves times a half is pi fourths. Pi times a half is pi halves. 3 pi halves times a half is 3 pi fourths. And then we have our pi halves times a half, which is pi. 1 times 2 is 2. 0, negative 2, 0, 2. There's our xy points of our official graph. So now we'll list out our maxes. So go to your y values. Isn't the highest y value going to be your max xy point or points? So right here, isn't over 0 up 2 going to be a max? Isn't over pi halves of 2 also going to be a max? Okay, let's go on to minimums. Isn't the lowest y value going to be the minimum? So there's our min, and then look, these are the x-intercepts, or the zeros, aren't they? X-intercept, 0, same thing. So that's how I would list it out on my test personally, because then that's completely stating it correctly here. All right, awesome. So just sometimes it takes a little bit of tricky, keeping a really watchful eye for what you can change it to be. That might be helpful. All right. Let's go to the next example here. Okay, it says find the sine of 2 theta, the cosine of 2 theta, and tangent of 2 theta, given cosine of just theta is 5 over 13. Now it tells us our theta is going to be between 3 pi halves and 2 pi. So obviously, guys, if cosine of theta is 5 over 13, we're not talking unit circle, are we? We're talking right triangle. So I would draw a right triangle, everybody, and I would put it in the correct quadrant. Now right here is 3 pi halves. Right here is 2 pi. Let's go ahead and draw in, since it says that theta is between 3 pi halves and 2 pi, we must have a right triangle in quadrant 4. So let's put in our theta closest to the origin here, and then our cosine is adjacent, so 5 over hypotenuse of 13. Now if we need to put any negatives on these we can, but isn't it positive 5 units, and our hypotenuse is always positive? So now we'll do Pythagorean theorem, 13 squared minus 5 squared equals question mark squared. You get 12 is equal to question mark. So this is a 12, but technically isn't it negative 12 since it's down? So negative 12. All right, now it says find the sine of twice the angle. You only have angle, not twice angle. Does everybody see? But we have a way of rewriting this so that it just has thetas instead of 2 thetas. So this was 2 sine theta. Cosine theta is an equivalent true statement. And then do you guys see how now we can calculate it? So that's equal to 2 times by the sine of theta. Our sine is opposite over hypotenuse, so that'd be negative 12 over 13. Times by our cosine of theta is adjacent over hypotenuse, which was 5 over 13. So if you wouldn't mind real quick, give me the simplified fraction of that. What is that real quick? What over what? What is it? And then did you times by 2? Oh, wait, no. And did you have 13 times 13? Jeez, we act like this is brain surgery. Negative 120 over what? Yes, that's true. All right. Do we have a problem with multiplying fractions? Were you guys confused? I'm literally asking in a genuine way. No? Okay, just making sure that we weren't confused because that took a long time. All right, let's move on to cosine of 2 theta. Now, once again, we only have cosine of theta, so we've got to change it so that in our equation we only have thetas. Well, we can use, remember with cosine of 2 theta, well, there were 3 different ones we could have used, correct? It doesn't matter which one you use. They are all the same mathematically. So I'm randomly choosing 1 minus 2 times sine squared theta. So then I would have a 1 minus 2 times by sine of theta times sine of theta. Guys, sine squared is just sine theta times sine theta. Do we know that? So sine of theta times sine of theta would have been negative 12 over 13 times negative 12 over 13. Now look at the math behind this, guys. This is all being times. So just type in your calculator 1 minus 2 times by this, and then hit math, enter, enter. Ready, go. Let's go quicker this time. Thank you. You said 119, negative 1 or positive? Positive, I think it's negative.
It's negative 119.
Okay, negative 119 over. Yep, it is 169 again. Now guys, to do tangent of 2 theta, we could do our formula, or even easier, don't we have sine over cosine? Don't we have sine and cosine? It's going to be much easier to just take your sine, divide it by your cosine. So we know that tangent of 2 theta is going to be our sine, negative 120 over 169 divided by cosine, negative 119 over 169. Dividing fractions, easy as pie, flip the second, multiply. So that'd be 169 over negative 119. So won't our tangent of 2 theta just be 120 over 119? Those divide out, or negatives divide out. 120 over 119. Okay, awesome. So just make sure that you understand, guys, if you're ever asked to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta, and you're only given stuff in terms of theta, you do have to change it. That's the point. All right. Doing good. We are now halfway through the lesson. All right, so this one says simplify sine of 3x, and they tell us show that sine of 3x is equal to sine of 2x plus x. Okay, so basically it's kind of starting us out in the right direction. It's like we don't have triple angle formulas, we only have double angle formulas, right? And we have some formulas for sine. That's what we learned last time. Addition and subtraction formulas for sine and cosine. So we would actually start on this side, and we would just start simplifying. Now just a reminder, this is a product formula, so doesn't it go, remember the sine of u plus v, didn't that become sine of u cosine of v? This is one we do need to have memorized. Plus cosine of u sine of v. Okay, cool. So let's go ahead and write it out. This is the same thing as sine of 2x cosine of x, I'm splitting it up the same way, plus cosine of 2x sine of x. So now you'd have to recognize, and then double angles technically are less simplified than just x. So we're going to then use trig identities again with our double angle formulas. So now we have double angle formulas we can use. So we're going to rewrite this as its equivalent form. So wouldn't that be 2 sine, you don't need to have the double angle formulas memorized, but it's 2 sine x cosine x. Then don't forget about, we still have this times by cosine of x. So this is all, let's write it 2 sine of x, and then cosine squared x. Okay, good? Now let's move on right here. The thing is the question is, cosine of 2x had 3 different things we can write it as, and it does not matter which one you choose. So, does anyone look at the 3 you have? Anyone want, once again, mathematically, aren't they all the same? Okay, so I don't know, pick one. Okay, 1 minus 2 sine squared x. Someone chose that, and then we still have times by sine of x, don't we? Oh, all that stuff times sine of x. Because isn't it this times this? So I have all this stuff times by sine of x. So wouldn't I probably distribute? Alright, so now we have 2 sine x, cosine squared x, plus sine of x again. And then don't we have minus 2 sine cubed of x? Alright, that's true. Any suggestions of what to do next? Maybe? Okay, good idea. So you're saying, I'm seeing a lot of sines. Maybe let's change our cosine squared into terms of sine. I like the idea. Let's see if that's going to help us. So we have 2 sine of x, and then we're timesing that by 1 minus sine squared. A Pythagorean identity. So I would distribute that here and here then. Let's see if that's nice and helpful. So that's 2 sine of x minus 2 sine squared x. Then we still have plus 1 sine x. Then we have minus 2 sine cubed of x. Let's combine any like terms. Do we see like some like terms? Isn't 2 sines of x plus 1 sines of x a like term? Yes.
So when you multiply the 2 sine of x and the negative sine squared of x, shouldn't that be a negative 2 sine squared of x?
Oh, yeah, that should be. So you're saying this should have been negative 2 sine cubed of x. Good catch. Does everyone see that I made that error? Okay, cool. Let's combine like terms. So we have 2 sines of x plus 1 sines of x is how many sines of x? 3. Okay, 3 sine of x. And then we have minus 4 sine cubes of x. We're just combining like terms. So why is that considered more simplified, you guys? Because once again, just x instead of 2x inside of the parentheses. So even though it doesn't really look that pretty. Yeah. We're just showing, they're just getting you started. Like, there's no way to show that how this is equal is it's getting you started. They're saying, take sine of 3x and write it as 2x plus x. Does that kind of make sense? I get what you're saying. We're kind of thinking of it as the previous examples that we've seen where we have equal signs. We've got to show that one side equals the other. Yeah, this one's kind of more like giving you, it says, show that this 3x is this sum with double angle formula. So basically, and then it just says, and use that to simplify. So it's getting us started. That's a valid question though. So once again, the reason this would be useful is because if I said to you, given sine of x is equal to 1/2, calculate sine of 3x, the only way to do it is to get it in terms of just x's. Does that make sense? And the only way to do that is to, since we don't have triple formulas, write it as an addition formula, and then to go through and simplify it down until you just have x's. But I get, yeah, that was it's kind of a weird feeling problem. In fact, first hour we thought we did it wrong, but then I went and looked in my book, and I'm like, no, that's what they were going for, which makes sense, I guess, because we would use that to then calculate if I said given sine of x is 1/2, what's sine of 3x? All right, these are the last formulas, and then we're gonna have 2 examples, and we'll call it good. We'll call it quits. These are half angle formulas. We just did double angle formulas. Now we're doing half angle formulas, because look, it's the angle divided by 2, angle divided by 2, angle divided by 2. I also will not make you memorize these formulas. So double and half angle formulas do not need to be memorized. You might want to make note to yourself that it says plus or minus, but we don't write plus or minus necessarily. It all depends on what quadrant we're in, our angle, what our U is in. Or actually we're going to go with what our original angle's in. You'll see what I mean, how we use this. So this is just a way, once again, if we have sine of u divided by 2, we can rewrite it as the square root of 1 minus cosine of u divided by 2. And notice once again, then on this right side here, it would have just a u instead of u divided by 2, so then we would be able to calculate stuff. Now we can switch back and forth, so it just depends on the context of the problem here. And then once again, if you have sine and cosine, then you could just do, for tangent, you could do sine over cosine, or you could use these formulas too. You already have these ones written down. All right, let's just start practicing them. Okay, so this says, find the exact value of the sine of 105. Now, there are 2 ways to do this one. I didn't specify. We are going to practice it with a half angle formula, but isn't there a addition formula we could technically use? What plus what? Sine of, you said 60 plus 45, yeah? That would be nice and easy, yes. Now, also, I'm just showing you an additional way to do it. We could use this is technically, guys, right here, is technically half of an angle that's on the unit circle, isn't it? Double it. What's the 2 times 105 is 210. So is it true that 210 divided by 2 is equal to 105? So this is a half angle. Does that make sense formula? So let's go put it in. This is equivalent to, so sine of 105 is the same thing as taking sine of 210 divided by 2. Same thing. This and this are the same thing. So let's go ahead and plug it into our half angle formula to calculate the answer here. So the sine of 105 is not usually able to be calculated an exact answer, but now that we have our sum and half angle and double angle formulas, we can find exact answers. Okay. So let's first figure out, is it plus or minus? So let's look at the original angle. Isn't 105 in quadrant 2? 105 degrees, everyone. So is the sign going to be positive or negative in quadrant 2? Positive, right? Okay. So we're going to put a positive. Then the square root of 1 minus the cosine of u. Isn't our u 210? So we're doing 1 minus the cosine of 210 divided by 2. Now we're just going to use our unit circle to simplify our radical. So we have the square root of 1 minus, isn't the cosine at 210 negative root 3 over 2? Did all over 2. Don't leave your answer like this. It's not considered simplified. We've got to do algebra. So that is our answer. We just got to have it prettier. So isn't that 1 plus root 3 over 2 all over 2? Which is equal to, I would get a common denominator in the top here. So I times by 2 times by 2. So we have the square root of 2 plus root 3 over 2. That's all up here. All over 2 divided by 1. So dividing fractions is easy as pie. This is the hardest part for people, is the algebra. Flip the second and multiply. So wouldn't 1 go on top and 2 go on bottom? So we have the square root of, we would distribute our 1 in, obviously. So 2 plus root 3 over 2 times 2 is 4. Can't I split up the top and bottom? Yes. So I'd have the square root of 2 plus the square root of 3 all over 2, because the square root of 4 is 2. And that's your exact answer. Now watch. Once again, type into your calculator the sign of 105. Make sure it's in degree mode. Curious. What decimal do you get? Point what? 0.966. Cool. So 0.96-ish. And then if you were to type this into your calculator, you'll also get that. But this is an exact answer where this is a rounded answer, you know? So you could check your answer, though. Awesome. Okay, last example of the day, and then the rest of the time will be yours to work on homework. And then I'll turn on Thunder Vision. Okay, so it says find all the solutions of 2 minus sine squared x is equal to 2 cosine squared of x over 2. I would write this down. And it wants the solutions on the interval from 0 to 2 pi. Notice there's a bracket around 0 and a parenthesis around 2 pi. So we'll have to pay attention to that. So technically this has parentheses around it. So now normally, guys, if this was just 2 minus sine squared is equal to 2 cosine squared of just x, we'd be good, right? We switch one of them to sine, we switch it all to cosines or all sines, right? The problem is it's not just x, it's x over 2. So you need to find a way to rewrite that so that there's just x's in the equation before you can continue. So let's rewrite this. We have 2 minus sine squared of x is equal to 2 times by, instead of this, what is that equal to? Yeah, this, isn't this and this matching up? Now guys, look, let me show you something. Cosine of x over 2 squared is the exact same thing as cosine squared of x over 2. They just put the squared right here, but it's the same thing. You guys understand that? So what is that equal to? The square root of 1 plus cosine, isn't it? Awesome. So I'm going to show my work for this one. Because we're in all the quadrants, I'm going to put plus and minus. We have the square root of 1, you're right, plus cosine of x over 2, and then it's all squared. So you're right. The square and the square root cancel out. You guys see what he's saying? So now plus and minus, both squared, are going to be plus. So now we can ignore the plus and minus. Square roots and squares cancel out. Now isn't this 2 times all that? So don't forget, we have 2 minus sine squared x is equal to 2. And then we have times by 1 plus cosine of x over 2. What happens with my 2's? Cancel out. So now we have 2 minus sine squared x equals 1 plus cosine of x. Now you're saying, I'm solving. When solving, I need to either isolate the trig function, but these are 2 different trig functions, can't do that, or get it so that we can factor it, set it equal to 0. Well, we have 2 different trig functions, so let's hurry and fix it so that they all have the same trig function. So we have 2 minus parentheses, 1 minus cosine squared, isn't it? Because we need it to be all the same trig functions, otherwise we can't factor it. So now I would distribute my negative through, So that's 2 minus 1 plus cosine squared x equals 1 plus cosine of x. So now everybody, what you're going to do is you're going to get it set equal to 0, aren't you? Isn't that how we solve these? If you have squareds and 1s, we're solving by factoring. So we need to get it set equal to 0. So I'm going to subtract 1, subtract cosine of x. Subtract 1, subtract cosine of x. So now that's 0. So right here, what's left? 2 minus 2. 0. Now cosine squared and cosine can't be combined, can they? So we have cosine squared of x minus cosine of x. When does that equal 0? So aren't we solving by factoring? So now we'll pull out a cosine of x. So then left, divide each term by cosine. Wouldn't that be cosine of x minus 1? And then we set each of them equal to 0. So when does cosine of x equal 0? When does cosine of x minus 1 equal 0? So the cosine equals 0 at x is equal to pi halves, doesn't it? Yep, and then it does want our interval from 0 to 2 pi, so we actually do need to list it out. Wouldn't the next place be 3 pi halves? And then when does cosine of x equal 1? 0. Now does 0 get included? Yes, bracket, so we need to list out 0. And 2 pi also, correct, is a solution. But because it's a parenthesis, we don't list it. What if it would have been a bracket? Then we would have needed to put 2 pi. Does that make sense? So the little details do matter. Awesome. Okay, that was the last example. So go ahead and use those to your advantage. The homework is on the paper. I would follow the paper versus my screen, just because I may have updated the paper. The rest of the time is yours, and I will put on Thunder Vision here in just a sec.